Hello, welcome to next session. In this session, we will solve some fluid mechanics question. The topic is fluid properties, fluid static, manometry, and buoyancy. Question number one: for a Newtonian fluid, option A shear stress is proportional to shear strain. Option B rate of shear stress is proportional to shear strain. Option C shear stress is proportional to rate of shear strain. Option D rate of shear stress is proportional to rate of shear strain. So according to Newtonian law, we have tau is directly proportional to du by dy. So du is the velocity of this layer and zero, and this layer is having zero velocity. So the difference of velocity in these two layers is du, and thickness of these two layers are dm. So this is the Newton's law. And suppose in time delta t, this layer moves by a distance dx, then du will be dx by dt. Okay, because du is its velocity. Okay, and now we can put here the value of du, that is dx by dt. Okay, so dx by dy makes, because this is your dx, this can be treated as arc and this can be treated as radius, so this will be d pi. Good, they are small quantities, so dx by dy can be written as d pi and divided by dt. So this is your rate of shear strain. So shear stress is proportional to rate of shear strain. So answer is option C. Okay. Next, match list 1 rheological equation with list 2 type of fluids and select the correct answer. List 1. Option A tau is equal to mu du by dy raised power n is equal to 1. List 2 Bingham plastic. Option B tau is equal to mu du by dy raised power n is less than 1. 2 Dalton fluid. Option C tau is equal to mu du by dy raised power n is greater than 1. Newton fluid. Option D, D is tau is equal to tau naught mu du by dy raised power n is equal to 1, and pseudoplastic fluid. So these are the codes. Okay, A, B, C, D, and we have to choose the right option. Okay, so we know that the Newtonian fluid is this. A is corresponding to 3, because this is the Newtonian fluid and n is 1. Newtonian fluid is 1. And for for this pseudoplastic fluid, n is less than 1, so that is 4. Okay, and for Dalton fluid, this n is greater than 1, so C is 2. And for Bingham plastic, it is there is some shear stress initially, and then constant shear stress, and then the shear stress increases. So then this is Bingham plastic. So we can see from this diagram also, Newtonian fluid is Newtonian fluid tau is directly proportional to du by dy, or n is 1. In Dalton fluid, the tau is equal to mu du by dy raised power n is 1, n is greater than 1. So in this fluid, the more shear stress is worked for the same change in du, change in velocity respect to y. Okay. More more than usual, because usually this, okay, so more shear stress will be in pseudoplastic, less shear stress will be. Okay, and this is your Bingham plastic, and in Bingham plastic there is constant shear stress at no velocity of fluid, and when the velocity generated, difference in velocity generated, then the shear stress also increases. So that is the constant, and this is the, okay, n is 1. Okay, so this is your pseudoplastic, and n is less than 1, less shear stress as compared to. So answer is option C. This is your 3. Okay, and B is your 4, this is your 2, and this is your 1. Okay, Next, figure shows the graph between shear stress and velocity gradient lines 1, 2, 3, 4, and 5 respectively. Represent ideal solid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid, ideal fluid. Option B, ideal fluid, Newtonian fluid, non-Newtonian fluid, ideal plastic fluid, ideal solid fluid. Option C, ideal fluid, ideal plastic fluid, non-Newtonian fluid, Newtonian fluid, ideal solid. Option D, ideal solid, ideal plastic fluid, non-Newtonian fluid, Newtonian fluid, and ideal fluid. So this is your as here there is no flow, this represents ideal solid. Okay, so 5 represents ideal solid, and that is in uh, this option, A option, B option, and in C option. This is your ideal fluid. Okay, because it is flowing and there is no shear stress developing, so this is ideal fluid. So ideal fluid, and this is your Newtonian fluid because it is following the Newton law. Okay, so Newtonian fluid. So answer is your B, ideal fluid, and then Newtonian fluid, and this is your ideal fluid, and this is your 3 is your non-Newtonian fluid. Okay, because it is not following the Newton law, and this is your ideal plastic fluid as we have discussed in the previous question. And again, this is so answer is your B. So this is your ideal. This is your ideal solid. This is Bingham plastic. This is ideal fluid. This is Newtonian fluid. This is Rolo plastic. This is ideal fluid, and these are the non-Newtonian fluid. Okay, so answer is option B. Next, choose the correct statement. One, viscosity of fluid or liquid increases with temperature. Two, velocity of gases increases with temperature. Option A, both A and 2, A and both 1 and 2. Option B, only 1. Option C, only 2. Option D, none of the above statements. So answer is viscosity of the gases increases with temperature, but viscosity of the liquid decreases with temperature. Okay. So answer is option C. Let us see the explanation. So below, viscosity of liquid is given by this tau mu naught 1 by 1 plus alpha t plus beta t square, where alpha and beta are constant, and mu naught is the viscosity at 0 T temperature. So viscosity of liquid decreases with temperature, and viscosity of gases is mu is equal to mu naught alpha t minus beta t square. Okay, and it is viscosity of gases increases with temperature, because when the temperature is increased, the mu will also increase. Okay. So there are other explanations for this also. Viscosity of any fluid depends upon the cohesive forces and molecular momentum characteristics. In case of liquid, the cohesive forces are prominent because the molecules are very close to each other. Okay, and with the increase in temperature, the cohesive forces decreases because they go apart. Okay, with the result of decreasing in viscosity. But in case of gases, the cohesive forces are small because of far much distance between the molecules. Okay, and molecular momentum transfer predominates. So as we increase the temperature, so this factor will increase the viscosity. Okay, so hence viscosity increases. So okay.